Hello everyone, and welcome to your Chem 113 review on solution stoichiometry with titrants, or titrations. My name is Jason, and I work for the ASU Tutoring Centers. Now, we're doing a titration here, a titration. So we are titrating chlorine into silver. Sorry, the other way around. We are titrating the silver into the chlorine. My apologies. And what that means is essentially we have, imagine like a beaker full of chlorine, not pure chlorine, but chlorine solution. So we have a bunch of little Cl- ions in there inside like a big beaker of water. And what we're doing is we're adding in the silver. So we have maybe like a solution of silver, and we're going to just be slowly adding that into our chlorine solution. And by doing this, we're actually going to be able to determine how much chlorine we have in our original sample before we added the silver in. This is very, very common technique, especially in acid-base chemistry. You titrate one solution into another solution to determine properties about the original solution. It's pretty interesting. So the idea here is we are going to be adding 0.1 molar silver into our solution up until the point when our reaction is essentially done. So essentially we just keep adding in our silver solution, and as we do so, we produce this solid product. So as we add silver, along the bottom of our beaker, we start to get this little solid precipitating because the silver is reacting with the chlorine. Now, if we keep doing this and doing this and doing this, more and more and more solid will start being produced until we run out of chlorine ions. Once we run out of our chloride ions, the amount of solid that's down here is not going to change because all of the chloride will have been reacted, so we can no longer form this silver chloride solid precipitate. So the idea is keep adding silver ions until we no longer see the precipitate forming. Okay, so imagine we do that. So we add our 0.1 molar silver solution for 20.2 milliliters. And then once we do that, we have now noticed that we no longer form the solid precipitate afterwards, and therefore all of our chlorine has been used up. So we can use this information to determine how much chlorine was in our initial solution. Based on these coefficients, that the silver and the chlorine are in 1-to-1 correspondence with each other. So the amount of silver needed equals the amount of chlorine needed for the solution. So how much silver did we use for this reaction to be completely done? We used 20.2 milliliters of 0.10 molar. So we can find the number of moles that corresponds to, right? If we have 0.100 molar, and again, that's moles per liter, and we go ahead and we multiply by our 20.2 milliliters, we get that it took 2.02 millimoles of silver. And since this was the amount needed to react with all of the chloride, this also equals the number of moles of chloride that we initially had. So we initially had 2.02 millimoles of chloride ions. And now that we know the number of millimoles, we can then convert this to moles, and then we can convert that to grams using the molar mass of chlorine. So 2.02 millimoles equals 2.02 times 10 to the negative 3 moles. And go ahead and take that and multiply by the molar mass. Oops. The moles cancel out. Multiplying across, we get 7.16 times 10 to the negative 2 grams of chloride ions. Okay? So that's how you do that. And again, that's the whole idea behind titration. We just added silver until we no longer saw precipitate forming, and then we used the amount of silver solution we added to determine how much chlorine was in our initial sample. Very powerful tool. So we're saying 7.16 times 10 to the negative 2 grams of chloride ions. And then if we look at part B, it says the sample has a mass of 10 grams. So what percent of the sample is chlorine? Well, using the amount of chlorine we have, we get that 7.16 times 10 to the negative 2 divided by the 10 grams gives us the percentage of chloride ions compared to the entire mass of the sample. And then, of course, we have to multiply by 100% to convert to a percentage, and that gives 0.176% chloride ions. So a very, very, very tiny percentage of the sample is actually chloride ions. Wonderful. All right, well, thank you for watching. As I mentioned at the beginning of the video, I work for the tutoring centers on campus. If you want more information about the free tutoring services that are offered on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. By going here, you'll be able to find a tutor on your campus or online that'll be able to help you with your specific course. Thank you again for watching, and I hope you have a fantastic day.